Hello students, welcome back. Now we are going to discuss one more interesting project, and that is a vending machine design. So in this video we are going to talk about that what is a vending machine, the working principle of a vending machine, how do we design it so that we can dispense some products, and we are going to code it using Verilog. So let us get started. So first of all, let us talk about our problem statement. A vending machine is going to automate the task of selling some products at some public places. Multiple products can be kept inside the same machine and they can have different price tags. The user can select that which product he or she want, and accordingly they will enter the money. The machine will take the input, which is money, and the selected product, and if the amount entered is more than the product price, then the product will be dispensed, and if there is any change that needs to be given back, that will also be given. So let us talk about a very simple vending machine design. We can say that we are having only one product in our machine. The user can have only 3 different types of currency notes, and based on the price of product, the machine will dispense the product and it can give the change. Later, we can extend this idea, we can add more products, we can add the support of more currency notes and all the available options. So here we have one such design. So we are designing a vending machine that is going to dispense a product whose price is 40 rupees, and this machine can accept only 3 currency notes, 10 rupees, 20 rupees and 50 rupees. So initially when nothing is entered, we are at S initial. If the user is entering 10 rupees, then we will traverse to S10. If the user is entering 20 rupees, we will go to S20, and the user is entering 50, then we will go to S50. So from the initial state, we have 3 different inputs, 10, 20 and 50. Now the product price is 40 rupees. If we are already having 50 rupees in the machine, that means we have more than the product price. So in that case, we will go back to S initial and we will say the output is 1. In all other cases, we will keep waiting for more money and output will remain 0. Now from 10, if we enter 10 more, we will go to 20. If we enter 20 more, we can go to 30, and from 10, if we enter 50, then we can go to 60. Now at 20 and 30, we are not getting the product, but at 60, we are getting the product. So from 60, we are going to traverse back to S initial. The product will also be given and change will also be given. Now when we are at 20, if we add 10, we go to 30. If we add 20, we go to 40. And if we add 50, then we go to 70. The user can enter the money in any order. So we have to take care of all possible cases. Now if we are at 40 and 70, the product will be given and we will be back to S initial. There is a difference now. If you are going back from 40, then no change is given. Whereas if you are going back from 70, then the change should be given. If we are at 30 now, from 30, if we add 10, we go to 40. If we add 20, we go to 50. If we add 50, then we go to 80. Now you can see that 40, 50 are already going back to as initial, and 80 will also be back to as initial. Here, one thing that we can observe now, that these states are not taking any input. That means whatever is the input, independent of that, it will directly go to as initial. S50, S70, S80, all of them, even S60. Now, once we are at 40, we are also going back. That means we are not accepting any more inputs. So once we are done with this, then we can go ahead and design it in Verilog. So here, let us talk about the aspects of Verilog design. The vending machine will be designed using the concept of finite state machine. That is clear because we have already designed the state diagram. The inputs will be fixed. We are having 3 currency notes, so a 2-bit input should be enough. The number of states will also be fixed. We can count how many states we are having, and from every state fixed number of transitions will be there. At every positive edge of the clock, machine will read the current state and the input value, and it will decide that what is going to be my next state and the output. If the system is having a sum that is more than the product price, which is decided as 40, then the product output will be 1, and we can also raise a flag which can tell that the change will be given. So testing cases should be very carefully designed, and we should test our machine very thoroughly for all possible cases. The inputs must be given before the rising edge of the clock. So when you are testing it, please make sure that your input is available before the rising edge, otherwise it will not be counted. Display the return whether you are giving a change or not, and we will also display whether we are giving the output or not. So now let us go to Vivado and test the system using Verilog. So here we have written the code. Our inputs are coin, clock and reset. These are the inputs, and we are having 2 outputs. One is Z, which is the product, and whether the change will be given or not. You can add more outputs and inputs as well, but this is the minimal design that can be taken. Clock and resets are 1 bit. There are 3 different types of coins or the currency notes, so that is why we need 2 bits. Output is product and change given. So first of all, we decide our states. Our states were S initial, S10, S20, S30, S40, S50, S60, S70 and S80. These were the states that we had. Total 9 states, and that is why we need minimum 4 bits. So 000 to 1000. So these are our 9 states. Then we define another parameter which is for the currency notes 10, 20, 50. For 10 the value is 0, for 20 the value is 1, and for 50 the value is 2. That means if I enter 0, basically I am entering 10 rupees. If I enter 1, I am entering 20 rupees, and if I enter 2, that is equivalent to 50 rupees. After that, the code is very similar to any FSM design that we have done. Here I have a state register and next state register which is of the size 4 bits, which is same as my size of state parameters. Then we say at the rate positive edge of the clock, if reset is 1, we are going back to as initial, otherwise we stay to the next state. Then at the rate state and coin. If coin is 10, in S initial. If the input is 10, we go to S10. If the input is 20, we go to S20. Otherwise, we go to S50. So this is simple 3 cases. If else using S initial. Then we go to S10. In S10, if the input is 10, then we go to 20. If input is 20, we go to 30. Otherwise, we go to 60. Similarly, for S20, if the input is 10, we go to 30. For 20, we go to 40. And for 50, we go to 70. In S30, if the input is 10, we go to 40. If the input is 20, we go to 50. And if the input is 50, we go to 80. Now something interesting. In S40, whatever is the input, our next state is S initial. In S50, 60, 70, 80, in all of these, we are not taking any input. We are directly going to S initial. Now let us talk about the product dispensing. If our state is S initial, we are saying no product is given, no change is given. S10, no product, no change. S20, no product, no change. S30, no product, no change. In S40, the product is given, but change is not given. In S50, 60, 70, 80, product is also 1 and change is also 1. So here we are defining the product will be given or change will be given or both will be given. And that is our code. Now let us simulate and test it. The simulation environment is ready. First of all, we define our clock, which is 0 to 1, 400 nanosecond, and we reset it to 1 and run it for 1 clock cycle, that is 100 nanosecond. Now what we can see that output and all of them have some finite value. After that, we will set our reset to 0. We don't need it anymore. And now we can start giving the values of coin. I give it 0. 0 means 10 rupees. Okay. So we start it. So you can see that the state is changing. I run for 1 more clock cycle. This is very important. This thing we had done in the FSM based pattern recognizers also. You should run for only 1 clock cycle. I set the coin value again to 0. That means again 10 rupees and I run it. So you can see the state is changing. 1 more, state is changing. Now I am having 30 rupees. 1 more and now I have 40 rupees. Output is there, no change is there. And after 40, the state will come to 0. S initial. Now let us give some other currency. Let me give 10 rupees first. Then I change force constant to 1. That means now I am giving 20. So 10 plus 20. Now I am having 30. I give 20 again. 30 plus 20, 50. So change is also given. Product is also given. And then we will back to S initial. Now we are back to S initial. Now if I give input 2, that means directly 50 rupees. So what we see, change is also given, product is also given. Next time it will be set to 0. If I give 50 again change is given and product is also given. Let us expand the whole simulation and check what is happening. So here we start giving 10, 20, 30 and as soon as we have 40, we have product. 10, 30 and we have 50. Product is also there, change is also there. And then we are giving 50. So product is also there, change is also there. So students, we are investigating different interesting projects. In the next video, we will talk about one more such product. So students, we are learning about different interesting projects. In our next video, we will talk about one more such project, and that is traffic light controller. Keep learning. Thank you.